threat modeling improved. This is a new application I've been working on to assist with threat modeling and enable collaborative features with either other humans or with machines in order to improve the quality and ease of building threat models. This consists of two parts. The first part, which is what I'll be demonstrating today, is the front end. This is a JavaScript application built on Angular with the material design theme. So it is localized and will support any number of languages, but I just want to call out that the localization is reactive and supports both right to left and left to right. This is designed to be hosted by you in your own organization in compliance with requirements for many OAuth providers. We include privacy policy and terms of service pages. We allow you to put your own information about whoever is operating the site in here, and you can use this, like I said, with any OAuth provider. It supports a number of different OAuth providers, and adding new OAuth providers is just as easy as modifying the configuration file to include your client secret, your client ID, and the URL information specific to your provider. I'll demonstrate logging in with the Google provider. So when you first log in, you're presented with a dashboard. The dashboard will show you cards for any threat models that you already have. I'll show you with some demo data. And then you can, of course, create new threat models as well. It also shows you any available collaboration sessions. And we'll talk more about collaboration shortly. So we'll click on a threat model. When you click on it, you're brought to the threat modeling edit page. You can see metadata about your threat model. We support multiple threat model frameworks, and adding a threat model framework is as simple as modifying a file in the source code directory. We support linking to issue trackers. Right now, you can just put in the issue URLs. Eventually, you'll be able to actually connect it to different issue trackers and create and link issues. We support data flow diagrams, linked documents like design specs, linked source code, and of course, the whole purpose is to identify and enumerate threats in the design. We have some metadata. Each threat model and each object in each threat model is assigned a UUID, and that's how we can uniquely track and link things to each other. We keep track of metadata, like the last time that it was modified and the time that it was created, who created it. We track users by their email address, and that's how we identify users from your OAuth provider, is we use your email address as the unique user ID. The main feature of the user interface is the ability to modify threat model data flow diagrams. And we support arbitrarily complex data flow diagrams with only a small number of data flow diagram shapes. Normal DFDs have what's called an external entity. We call it an actor, but they also contain processes, stores, and we add two utility shapes, which are the security boundary and the text box. The text box is not active, it doesn't do anything, but it just allows you to add visible documentation to threat model to data flow diagrams. Security boundaries allow you to define where the limit of enforcement of security control is. So we can create a security boundary, and then we can move shapes inside the security boundary. And now the threat model has captured this embedding, and it understands that this security boundary surrounds these objects, and we can actually use this for reasoning. Notice also that data flows are expressed unidirectionally. This allows us to do graph analysis against the data flow diagram, and we can annotate inbound and outbound data flows with separate metadata. We can create new shapes. And modifying data flows is as easy as dragging them. Modifying shapes is as easy as dragging them. And so you can capture the relationships between things. You can rename things by either right-clicking and typing in a new label, or you can double-click what we call node shapes, and you can directly edit the label. Each component in your data flow diagram can have arbitrary metadata associated with that. So this enables you to provide information that can be used for automated analysis. And we can also add threats. Threats have a name, and a threat type, which is based on the framework that you chose when you first created the threat model. Severity, priority, and score. Eventually, score will have a CVSS calculator behind it. And priority is completely up to you. It's a free-form text field that you can use for your own purposes. Again, we want to integrate this with issue trackers. So we have an issue URL field, a status field, and fields to link the threat to specific objects in the data flow diagram, or it can be linked directly to the threat model itself. Finally, we have a checkbox that you can check to indicate a threat's mitigated. All of this information is exposed through an underlying API. The API is documented in an open API specification, version 3.0. So it is very easy to integrate into other programs to have programmatic access to the threat model server. We support undo and redo. Whoops. And we support export of the diagram itself as an image. And we support export of the threat model itself as a JSON file. The threat model has permissions associated with it. As I said, we identify users by their email address that's attested to by the OAuth provider. And we have a very simple role model with reader, writer, and owner. Reader cannot perform any mutating actions. Writer can perform mutating actions, but they cannot delete or change permissions. And owner can do anything. You can add permissions. And allow other people access in that manner. As I said, every single object has a metadata set of fields associated with it, or an array of metadata associated with it. These are stored in key value pairs and are programmatically accessible by key or value. And the last feature I will show you is the collaboration feature. This is designed so that multiple users can interact on the same threat model data flow diagram at the same time. So when someone wants to collaborate, they start collaboration. We'll show the list of collaborators here. You can copy a link and share it in your sharing mechanism of choice, Slack or email or whatever. The other user gets the link, they click it, they may have to authenticate, and then they will be presented with the same diagram as you. When they make changes to the diagram, those changes will show here with an indicator of who made the change. And when you make changes, your changes will propagate to their user interface, and they'll see that you were the one that made the change. And in that way, people will be able to collaboratively whiteboard a design, clarify any misunderstandings about components and data flow, and build a model that will accurately represent the underlying application. And then you can end collaboration as well. So that is the basic experience of TMI, and both the web application and the service are hosted on GitHub, and you'll be able to find the links where this video is posted. Thank you.